Hello again, and welcome to another episode of my Machine Learning the Basics series. In this episode, we are going to re-implement the same algorithm that we did in the last video, but instead of implementing all of the math ourselves, we're going to use libraries to assist. There's nothing wrong with using libraries to assist, but I wanted to show what it was like implementing these things without having the assistance. A lot of the times, the difficulty in machine learning has to do with switching algorithms, trying out different ways of calculating numbers, or trying to find different ways to get maybe the result set that you're looking for. As such, it takes a lot of time to manually implement an algorithm just to find out that it doesn't work right. So most of the time we use pre-existing algorithms, and we also teach and train these algorithms based on our needs. Well, let's go ahead and get started. Over here is our old code. As you can see, we have just pandas and POW imported from math, but all we really need is pandas because we're not going to use math. We're going to use pandas to populate our CSV data, just like we did over here. So let's just go ahead and copy that. Now that we've gone ahead and moved this over to our new file, we're going to need a couple of new libraries. One of the things we're going to need is NumPy. So I'm going to start by importing some stuff from NumPy here. We're going to import NumPy as NP just to make it easy to access. One of the new libraries we're going to need is sklearn. So what I'm going to do is pop open a console down here and type in pip install sklearn. This is going to make sure that I have it installed on my system. Now, obviously, I do have it installed on my system, but you may not. So make sure that you check that you have it installed. Now, from sklearn, the linear model, we're going to import linear regression. This is going to, in essence, fully encapsulate all that we have done in a single major import. Yes, we have to have data, and we will need to reshape our data to make it work perfectly, but this is a pretty useful thing for us. Now what we're going to do is define our X and Y coordinates. What we're going to do is we're going to take the data that we have from the CSV file, and we're going to put those into NumPy arrays. Then what we're going to do is we're going to call this reshape command. What reshaping does is it allows us to fill one side or another of a 2D array if we only have a 1D array. In this case, we only really have a 1D array for the data because the date is going to be our X, and then the actual population will be our Y. So we don't really have a second corollary function to actually use. We'll have no data for that axis. So instead, what we're going to do is reshape the data. So the -1 basically means there shouldn't be data here, and the 1 means that there should be data. So this will reshape our array into a 2D array with the things that we need. We'll also define our Y here. There's no need to reshape this data because Y is very commonly a single axis, so it doesn't require a 2D array. Now we're going to define our model. Our model is going to be the linear regression, and then we're going to fit the model. Fit is a fancy way of saying training, and you're going to hear it a lot in machine learning, and in this series I will use it as well. However, keep in mind that fitting something does not necessarily mean that you are testing it. So you will have to fit to train, and then you will have to test as a separate step. Some libraries and some algorithms do have a fit and then train kind of function, but usually those are pretty explicit when you use them. I'm just putting in R square here as a model.score. Sometimes when you make an algorithm or you're testing some values, you want to get the overall score of how accurate or inaccurate you are. In this case, we're just going to save this as RSQ and we're just going to ignore it for now. Corpus guess, we're going to save this here as, just like we did in the previous episode, we're going to be predicting and then saving it into the guess column in our CSV data. As you can see here, we actually aren't using pretty much anything like we would have in our implementation. We don't need to know the variance, the covariance, the difference squared, our difference, anything along those lines, because the linear regression model itself here already has all that built in. So we can just simply use it, put our numbers in, and predict. So let's go ahead and actually run this code. All right. We see no errors here. This is what we expect. Let's open up our variable viewer. As you can see, our score is 0.99, which is looking good. Let's open up our corpus here. Let's make this guess column a little bigger. As you can see, our values are actually pretty close. They're probably the same, if not very close, to our manual implementation of this algorithm. You'll see that we have quite the similar distribution of not only our guess to our value. This is one of those things where we want to check more than just a few values, but let's go ahead and scroll and see what we have here. Yep, they're looking pretty close. I'm definitely pleased with this outcome. So I hope you learned something, and I hope you join us for the next one, where we actually build a graph to visualize this data. But until then, peace.